Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll explore how Amazon Managed Streaming for Apache Kafka, or Amazon MSK, simplifies the setup, scaling, and management of Apache Kafka clusters in the cloud. We'll start by understanding what Kafka is and why it's essential for modern real-time data streaming applications. Then, we'll dive into how Amazon MSK automates much of the heavy lifting, including provisioning, configuration, monitoring, and security. Let's get started. In today's digital landscape, organizations are experiencing an explosion of real-time data. From IoT sensors, mobile apps, financial transactions, to clickstream activities, the volume, velocity, and variety of streaming data are growing at an unprecedented rate. Managing this tidal wave of information brings significant challenges. Deploying and operating Apache Kafka clusters on your own is inherently complex. Teams must meticulously configure brokers, manage zookeeper nodes, set up replication strategies, partition topics, and fine-tune performance across multiple environments. Beyond setup, the operational overhead of traditional deployments is immense. Scaling clusters to meet peak demand, rolling out patches and upgrades, handling node failures, and ensuring consistent throughput require constant vigilance and deep Kafka expertise. High availability and durability are critical requirements for modern streaming platforms. Businesses expect real-time applications to operate 24/7 without data loss. Achieving this level of resilience demands sophisticated architectures that replicate data across multiple availability zones, automate failovers, and guarantee message durability, often adding layers of infrastructure and operational burden. And then there's the integration challenge. Kafka is only part of the story. Streaming data must be consumed by downstream systems such as databases, data warehouses, machine learning pipelines, and analytics platforms. Building and maintaining reliable, scalable, and secure integrations across this diverse ecosystem often requires extensive custom development, careful data governance, and ongoing operational support. On top of all this, organizations must be able to scale Kafka dynamically. Real-time workloads can be unpredictable, with sudden spikes that traditional static infrastructures struggle to absorb, without compromising performance or reliability. Amazon Managed Streaming for Apache Kafka, or Amazon MSK, offers a fully managed service that takes the complexity out of running Kafka clusters at scale. Instead of spending time provisioning hardware, configuring brokers, and handling maintenance tasks, organizations can rely on MSK to manage the infrastructure while they focus on delivering real-time applications. MSK runs the same open-source Kafka versions, ensuring complete compatibility with your existing Kafka clients, tools, and applications. This means you can migrate to MSK or integrate with it without rewriting or modifying your existing code bases. High availability and data durability are built into the foundation of MSK. By automatically replicating data across multiple availability zones, MSK ensures that your streaming data remains safe and accessible, even if an underlying infrastructure failure occurs. As data volumes grow and workloads fluctuate, scaling becomes critical. Amazon MSK provides automated scaling capabilities, allowing clusters to adjust both broker count and storage capacity without downtime. This elasticity means you can seamlessly handle traffic surges, seasonal variations, or sudden spikes without worrying about over-provisioning or bottlenecks. For those looking for an even simpler operational model, Amazon MSK Serverless offers a powerful alternative. With MSK Serverless, there's no need to provision or manage cluster capacity at all. The service automatically scales resources up and down based on the needs of your streaming workloads, making it ideal for unpredictable or highly variable traffic patterns. Underneath it all, MSK dramatically simplifies operations with managed brokers. Tasks like patching, upgrading, monitoring, and handling failures are all automated, reducing operational overhead and freeing up teams to innovate faster. With comprehensive monitoring built into AWS tools like CloudWatch, administrators have the visibility they need without the operational burden they don't. To truly understand how Amazon MSK works, it's important to grasp the core concepts of its architecture. At the heart of MSK is the cluster, a managed group of Kafka brokers that spans multiple availability zones to ensure high availability, resilience, and seamless scalability. MSK takes care of provisioning, maintaining, and healing these clusters, so you can focus on your applications rather than infrastructure management. Within the cluster, you'll find brokers, individual Kafka servers responsible for storing data, handling producer and consumer requests, and coordinating with each other for distributed operations. Each broker manages a portion of the data and is crucial to scaling throughput horizontally. Kafka organizes messages into topics, which are essentially logical channels for publishing and consuming records. When a producer sends data, it writes to a topic, and when a consumer reads, it subscribes to a topic. This decoupling of producers and consumers through topics allows for highly flexible and scalable communication patterns. Topics are further divided into partitions, which are the fundamental units of parallelism in Kafka. Each partition is an ordered, immutable sequence of records. Distributing partitions across multiple brokers allows MSK to handle massive volumes of data with high concurrency and low latency. To protect against data loss and ensure resilience, MSK employs replication. Each partition is replicated across multiple brokers, and one broker is designated as the leader for each partition. If a leader broker fails, MSK automatically promotes a replica to maintain availability with minimal disruption. Finally, under the hood, MSK provisioned clusters still rely on Apache Zookeeper, a coordination service that manages metadata, broker health, and leader elections. The good news is that MSK fully manages Zookeeper on your behalf, handling the provisioning, patching, and scaling, so you never have to interact with it directly unless you really need to. Let's take a closer look at the Amazon MSK architecture. At the top of the diagram, you'll see the Amazon MSK Managed VPC, the control plane. This is where the critical cluster management components reside. Within each availability zone, two key elements are deployed. The Zookeeper nodes, highlighted in blue. These nodes play a vital coordination role for the Kafka cluster. They are responsible for tasks like leader election, maintaining configuration information, and keeping the brokers synchronized across the cluster. The broker nodes, shown in green. These brokers are the heart of Kafka. They store the data, handle producer rights, serve consumer reads, and manage partition leadership. They are the primary touchpoints for your streaming workloads. Below the control plane is the application VPC, the data plane. This is where your applications live and interact with the Kafka infrastructure. Each Zookeeper and broker node is connected to an elastic network interface, which acts as a secure and scalable network bridge between the managed MSK control plane and your application's environment. In AZ1, the producers, your applications or services, are generating and sending data to the Kafka brokers. In AZ2, the consumers are running, retrieving, and processing data from the brokers for downstream use, such as analytics, storage, or real-time decision-making. And in AZ3, you'll find cluster operations, administrative tasks such as monitoring, maintenance, scaling activities, and controlled upgrades taking place. This distributed multi-AZ architecture ensures that your Kafka cluster is resilient to individual zone failures, providing high availability for your streaming data pipelines. Finally, the clear separation between the control plane and data plane not only enhances the security posture by isolating management operations from application data flows, but also offers greater operational flexibility. Amazon MSK offers two primary deployment options: MSK provisioned and MSK serverless, allowing you to tailor your Kafka architecture to your application needs. With MSK provisioned, you have full control over the architecture and configuration of your Kafka clusters. You can carefully select the brokered instance types based on your workload characteristics, whether that means optimizing for compute-intensive operations, memory-heavy use cases, or high-throughput network performance. You also have the ability to set the number of brokers in the cluster, allowing you to fine-tune the balance between fault tolerance, scalability, and cost efficiency. Storage capacity per broker is configurable as well, giving you the ability to design for long data retention periods, high ingestion rates, or growing dataset sizes. As your data volumes increase, MSK Provisions supports elastic storage, enabling you to expand storage seamlessly without service interruption. This deployment model is particularly well suited for steady, high-volume workloads where performance predictability and granular control are critical, such as financial trading platforms, real-time analytics systems, or industrial IoT networks. MSK provision clusters require active monitoring of metrics like CPU utilization, disk throughput, partition distribution, and consumer lag. While Amazon MSK automates much of the undifferentiated heavy lifting, customers are still responsible for scaling decisions, right-sizing resources over time, and ensuring that the cluster remains optimized for cost and performance as workloads evolve. On the other hand, MSK Serverless takes simplification to an entirely new level. With MSK Serverless, you no longer need to worry about provisioning, configuring, or managing any of the underlying Kafka infrastructure. There are no clusters to size, no brokers to maintain, and no storage volumes to monitor. Instead, the service abstracts away all the operational complexity, automatically adjusting compute and storage resources in response to the real-time demands of your applications. As your data streams grow or shrink throughout the day, MSK Serverless seamlessly scales to match, delivering the right amount of resources without manual intervention or complex scaling policies. This elasticity makes it ideal for workloads that are unpredictable, spiky, or highly dynamic, such as event-driven applications, ad tech platforms, gaming telemetry, or user activity tracking, where traditional capacity planning would either lead to costly over-provisioning or risk under-provisioned bottlenecks. MSK Serverless also uses a pay-per-use pricing model, where you are charged only for the volume of data you stream and store. This makes it cost-effective for applications with variable usage patterns, and it allows teams to focus entirely on developing and deploying streaming solutions without worrying about back-end operations. Choosing between the two depends largely on your workload characteristics and operational preferences. MSK Provisioned is ideal when you need granular control and can predict your resource needs, while MSK Serverless is the better option when you need to move quickly, handle fluctuating demand, and minimize infrastructure management. And as your requirements change, migration strategies such as dual-write architectures or phased cutovers allow you to transition between deployment models without major disruptions. Amazon MSK offers a wide range of data integration options, making it easy to build powerful streaming applications that fit seamlessly into your existing AWS ecosystem. One of the key advantages of MSK is its native integration with AWS services. AWS Lambda functions can directly consume data from MSK topics or produce events into MSK without the need for additional infrastructure. This makes it incredibly easy to create serverless, event-driven architectures where functions automatically respond to new data in real time. For more advanced stream processing, you can use the managed service for Apache Flink. This service allows you to run real-time SQL queries on streaming data flowing through MSK, enabling use cases like anomaly detection, predictive analytics, and dynamic alerting, all with minimal operational overhead. In addition, AWS Glue provides a robust way to build ETL pipelines with streaming data. Glue connectors and jobs can pull data from MSK topics, perform complex transformations, and load the results into a variety of destinations such as Amazon S3, Redshift, or relational databases. This makes it simple to build end-to-end data processing workflows that start with live streaming events. Beyond these native services, MSK Connect offers another powerful integration option. MSK Connect provides fully managed source and sink connectors, dramatically simplifying the task of moving data between Kafka and external systems. MSK Connect handles the heavy lifting, including scaling, patching, and monitoring, so you can focus on building your application logic instead of managing the infrastructure. Finally, MSK is a strong foundation for implementing change data capture, or CDC patterns. With CDC, changes in databases like MySQL or PostgreSQL can be captured in near real time and streamed into Kafka topics. From there, they can be consumed by downstream applications for real-time analytics, synchronization, or even microservices communication. Kafka Streams is a powerful, lightweight Java library that allows developers to build real-time stream processing applications directly on top of Kafka. Instead of requiring a separate cluster or external processing framework, Kafka Streams empowers you to design applications that consume, process, and produce data back into Kafka topics, all within your existing application environment. Kafka Streams applications work natively with Amazon MSK without the need for any custom adaptations or proprietary integrations. You simply configure your application to connect to your MSK cluster's Bootstrap servers, and you are ready to start building streaming logic immediately. One of the key strengths of Kafka Streams is its support for both stateless and complex stateful operations. It's ideal for simple transformations like filtering or mapping events. But it also excels at more sophisticated workloads, performing joins between multiple streams, windowed aggregations, and sessionized event processing, all while maintaining scalability and resilience. Reliability is baked into the design. Kafka Streams supports exactly once processing semantics, ensuring that each record is processed once and only once, even in the event of application crashes or Kafka rebalances. Under the hood, Kafka Streams achieves high durability and fault tolerance by using Kafka topics to persist intermediate processing state and changelogs. If a processing node fails, Kafka Streams can recover state by replaying data from these durable logs without requiring external state management systems. For low latency access, Kafka Streams also supports local state stores. These are embedded key value stores within the application itself, allowing for extremely fast reads and writes. You can even expose this local state via interactive queries, enabling external systems to fetch the current state of stream computations in real time. Amazon MSK provides a rich set of advanced processing features that help developers build resilient, scalable, and intelligent streaming data applications. One of the most critical capabilities is partition management and rebalancing. In Kafka, partitions determine how data is distributed across brokers and consumers. MSK provides fine-grained control over partition strategies and supports dynamic rebalancing of consumer groups. This ensures that as workloads scale or consumer instances change without manual intervention or disruption. To address the challenge of retaining large volumes of data over time, MSK supports tiered storage. Tiered storage automatically moves older data from hot storage to a lower-cost, durable storage layer, while still making it available for real-time access. This enables organizations to keep streaming data accessible for much longer periods without incurring high infrastructure costs. Another key feature is exactly once semantics. In traditional streaming architectures, duplicate records can occur due to retries or system failures. MSK addresses this by guaranteeing that each message is delivered and processed exactly once. This is essential for use cases like financial transactions and billing systems where data integrity must be absolutely preserved. Managing data formats across distributed producers and consumers can be complex and error-prone. By integrating with AWS Glue Schema Registry, MSK allows you to enforce schema validation at runtime, control schema evolution, and ensure compatibility as your applications evolve. This reduces serialization errors and improves overall system robustness. Finally, MSK supports cross-region replication using tools like MirrorMaker. This enables you to replicate Kafka topics across multiple AWS regions, which is critical for building disaster recovery solutions, ensuring high availability, and optimizing global data access for multi-region applications. Scaling and performance optimization are crucial aspects of running an efficient Amazon MSK deployment. Horizontal scaling involves adding more brokers or partitions to spread the workload across multiple resources. This improves parallelism and resilience, but can introduce complexity in partition management. Vertical scaling, on the other hand, focuses on upgrading the broker instance types to more powerful hardware, delivering better performance per node. Partition management plays a key role in maintaining optimal performance. Properly sizing the number of partitions ensures that the load is evenly distributed across the brokers and consumer groups. Too few partitions can create bottlenecks, limiting concurrency, while too many can introduce unnecessary overhead and complexity. Another critical factor is topic configuration optimization. Kafka topics come with settings like replication factor, segment size, retention policies, and compression type. all of which influence how efficiently data is stored and transmitted. Fine-tuning these configurations can dramatically impact system performance, improve disk utilization, and reduce the load on brokers. On the client side, producer and consumer tuning is equally important. Adjusting parameters like batch size, linger time, compression settings for producers, and fetch sizes for consumers can optimize data flow through the system. MSK clusters must also be designed to handle traffic spikes effectively. Techniques like auto-scaling, buffering, and implementing back-pressure controls allow the system to absorb sudden increases in data volume without experiencing downtime or data loss. Finally, it's essential to weigh the cost versus performance trade-offs carefully. Over-provisioning infrastructure guarantees performance but can be expensive. A well-architected solution balances broker sizing, partition strategy, and replication configurations to optimize performance while keeping operational costs under control. Security and compliance are critical considerations when working with streaming data, and Amazon MSK is built with strong protections to meet enterprise-grade requirements. MSK ensures that all data is encrypted both in transit and at rest. Data moving between producers, brokers, and consumers is encrypted using TLS, while data stored on broker volumes is protected using encryption keys managed through AWS Key Management Service. You have the option to use AWS managed keys or bring your own customer managed keys for added control. You can authenticate clients using IAM roles and policies, TLS mutual authentication for certificate-based access, or SASL Scram for username and password-based credentials. This gives you the flexibility to integrate MSK securely into a variety of application architectures, whether they are AWS native, hybrid, or third-party systems. MSK also supports fine-grained authorization and access control. You can apply Kafka Access Control Lists, or ACLs, to manage permissions at the cluster, topic, and consumer group levels. Additionally, IAM-based policies can be used to tightly control who can perform operations like creating topics, writing messages, or modifying cluster configurations. To further enhance security, MSK supports client-side encryption and data signing. Sensitive data can be encrypted or cryptographically signed by producers before it even reaches the Kafka broker, providing an additional layer of protection against unauthorized access or tampering. Compliance is another area where MSK shines. The service is certified for major compliance frameworks including SOC, ISO 27001, PCI DSS, and HIPAA, making it a strong choice for customers with regulated workloads in industries like finance, healthcare, and government. This built-in compliance helps reduce the burden of meeting your own organization's audit and regulatory requirements. When considering Amazon MSK for your streaming workloads, it's important to understand how the pricing model works to accurately forecast costs and optimize your architecture. In MSK Provisioned, you primarily pay for the broker instances you run. Each broker is billed hourly based on its instance type and size, giving you predictable costs when you know your workload requirements in advance. This model is ideal for stable, high-throughput environments where control over cluster resources is essential. Along with instance costs, there are storage charges in the provisioned model. You are billed per gigabyte per month for the amount of storage you allocate to your brokers. If your storage needs increase beyond the original allocation, MSK offers elastic storage expansion, which automatically scales your storage and adds incremental charges based on the additional usage. Data transfer is another component of MSK pricing. While traffic between brokers within the same cluster is included at no extra cost, data that moves out of the cluster, for example, to external AWS services or across regions, incurs standard AWS data transfer fees. If you choose MSK serverless, the pricing model shifts to a true pay-as-you-go approach. With MSK serverless, there are no cluster or broker management costs. Instead, you are charged based on two primary factors: storage consumed and throughput used. Throughput is measured separately for data written into the service and data read from it, and each is billed according to input and output rates per gigabyte per hour. This model is particularly cost-effective variable, spiky, or unpredictable workloads, where provisioning static infrastructure would be inefficient or expensive. Additionally, if you integrate with external systems using MSK Connect, There are separate charges for connector usage. Billing is based on the compute capacity assigned to each connector, measured in MSK Connect units per hour. This ensures that connector costs scale predictably with your integration demands. Managing costs effectively in Amazon MSK starts with careful planning and optimization at every layer of your architecture. First, it's important to right-size your broker instances based on the specific characteristics of your workloads. Instead of defaulting to larger instance types, you should analyze your compute, memory, and network throughput requirements and select the most appropriate configuration. Next, optimize your partition and topic design. While partitions are essential for scaling Kafka, having too many, especially unused or low-traffic partitions, can lead to unnecessary broker overhead and higher costs. Similarly, creating a large number of idle topics can inflate resource consumption without delivering value. As your data grows, it's crucial to monitor data growth and retention policies. Elastic storage is a powerful feature in MSK that allows brokers to automatically expand storage as needed, but it can also introduce unexpected costs. To further optimize resource utilization, tune your producer and consumer configurations. Adjusting batch sizes, enabling data compression, and fine-tuning acknowledgement settings can significantly improve throughput while reducing resource strain on brokers. For users of MSK Connect, when you need dedicated compute for connectors, consider taking advantage of reserved instances for EC2. If you have predictable, long-running connector workloads, reserved pricing can offer substantial discounts compared to on-demand compute costs, dramatically reducing your total cost of ownership over time. Finally, for unpredictable, spiky, or low-duty cycle workloads, leverage MSK Serverless because it automatically scales with your application's needs and charges you based on actual usage. MSK Serverless can prevent the wasteful expense of provisioning for peak capacity that is rarely reached. Monitoring is critical for maintaining the health, performance, and security of your Amazon MSK clusters, and AWS provides a rich set of tools to give you full operational visibility. One of the primary mechanisms is Amazon CloudWatch metrics. MSK automatically publishes key broker and topic level metrics to CloudWatch. These metrics give you real-time insights into cluster health, throughput, storage utilization, and networking performance. MSK also offers enhanced monitoring levels, giving you control over the depth of visibility based on your needs and budget. You can choose basic monitoring, per broker monitoring for a more detailed view of each broker's resource utilization, or per topic and per partition monitoring for granular performance analysis. Another critical capability is CloudWatch logs integration. MSK can export broker logs such as server logs, controller logs, and client authentication logs to CloudWatch logs. This enables detailed troubleshooting, auditing connection patterns, and diagnosing broker or client issues when anomalies arise. Additionally, AWS CloudTrail integration allows you to capture API-level activity for MSK clusters. Every cluster creation, configuration change, or security policy update can be logged and audited through CloudTrail. For teams using open-source monitoring solutions, MSK supports open monitoring with Prometheus. With open monitoring enabled, you can scrape broker-level metrics using Prometheus and visualize them using tools like Grafana. Finally, MSK is designed to integrate seamlessly with third-party monitoring tools like Datadog, New Relic, and Splunk. If your organization already has investments in external observability platforms, MSK makes it easy to extend those tools into your streaming infrastructure without disruption. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.